Welcome to Lesson 9, Part 2. In the previous lesson, we made a new contract, dummy token, and in this lesson, we will compile and deploy this token on test.rpc node using truffle. The first thing that we need to do is to make a new directory in which we will initiate a new truffle project. So let's do that. So we are in the right directory. Now initiate the truffle project. And now you can see the several functions or commands which are available. So truffle compile, truffle migrate, and truffle test. In this lesson we will use truffle compile and truffle migrate, which is also an alias for truffle deploy. So the first thing we need to do is to open this directory with our text editor and remove all the contracts besides the migrations contract, which is used to keep track of migrations. Now let's copy the dummy contract which we made previously. I have it in the GitHub repository and I will copy it to contracts directory. So here we go, we have it available. And now let's change this file, deploy contracts, and change metacoin to dummy token. And let's remove the lines 5 and 6 and the first line and only leave the dummy token for deployment. Now the next step is to make sure that test.rpc node is running. So go to the new terminal window and type test.rpc. As we can see, the node is now running and we have several accounts ready for testing. Go back to the previous window and type truffle compile, which will compile our contract. Now here we have an error and it's saying that the source file requires different compiler version. At the moment, truffle is using compiler version 0.4.15, so we cannot go above that. Well, that's not a problem because we do not use any new features of Solidity, so let's just adjust this from 18 to 15 and try to compile again. It worked successfully. Now let's deploy this contract using command truffle deploy. We can also use truffle migrate. And as you can see, the contract has been deployed successfully. And here we should also see several transactions which happened when we were deploying the contract. So one of these, this one, is the transaction where the contract has been created. Cool. Now let's go back, clear up the terminal and type truffle console. Okay, so now we are in the truffle console. What this allows us to do is to interact with the test.rpc node and test our smart contract. For example, we can type web3.eth.accounts and it will return all the accounts available for us to use. And if you notice, the first account starts with 0x, 3d, 19aef and so on. And this matches the account which was created for us here in the test.rpc node. And if you compare all the other accounts, you will also see that all of these match. So these have been created for us automatically by test.rpc just for testing purposes. They are not real accounts. Now, in order to test our smart contract, we need to retrieve an instance of it, and we do that by typing dummy token deployed then function instance app equals instance. And what this gives us is an app variable to which we have declared a dummy token instance. And if we explore it, we can see that it has all these functions that we declared: the total supply, the transfer from, the balance of, and so on. Now we will try to interact with it, but before we do it, let's declare the 3 accounts we will use for testing. So we can do that by typing var acc1 equals web3.eth.accounts 0 So that's our first account. Then this is our second account. And then this is our third account that we will use. So we have these three accounts, ACC1, ACC2, ACC3. And now let's mine some coins from account 1. And we do that by typing app.mine from ACC1. And what this does, it executes a transaction where an account 1 mines some tokens. So let's do that several times. Let's say we do that 5 times. And now if we check the balance of that account by typing app.balance of account 1, we can see this kind of weird syntax, but the relevant number for us is number 5, which shows that we have 5 tokens, or to be exact, the account 1 holds 5 tokens. Now let's do the same for account 2. So we mine some tokens from account 2. We do that also 3 times, and if we check the balance of account 2, we have 3 tokens. Perfect. Now let's try to transfer some tokens from account 1 to account 2. We do that by typing app transfer account 2. Then we transfer all of our tokens, let's say 5 of them, if I'm not mistaken, and we call it from account 1. Now if we check the balance of account 1, the balance will be 0, and the balance of account 2 should be 8. And also the total token supply should be 8, which is correct. By the way, notice how for balance of or total supply functions, I do not execute the from JSON object. Like I do not include the extra parameter of from to show which account is being used to call the function, like I do here, for example, where I transfer the tokens. This is because the balance of and the total supply functions do not alter the state of blockchain and thus do not cost any gas to use, but the transfer function changes the state of the blockchain, and these changes have to be propagated through the blockchain and executed on all the machines running Ethereum nodes. Thus this transaction costs, and we have to specify which account will pay for this transaction. Now let's try to see how approve works. So we will approve an account 2 to spend 10 tokens from account 1. We do that by typing app.approve account 2 10 from account 1. And now if we check allowance of how many tokens account 2 can spend from account 1, we should get 0, surprisingly, or not surprisingly for some of you. And this is because account 1 doesn't even have 10 tokens to spend. And if we look at the code of our contract, if it doesn't have enough tokens in its account, this function returns false and does not execute. And actually, right now the balance of account 1 is 0. So we need to mine some coins. So let's do that. Let's mine 3 coins to account 1. Okay, let's do 5 coins. And now let's do approve again. But this time we allow the account 2 to spend all 5 coins from account 1. And if we check allowance again, it should be 5, which it is. Now let's use this privilege and try to send some money from account 2 to account 3 using account's 1 balance. And we do that by typing app.transfer from account 1 to account 3. And let's say we send 3 tokens. And we execute this command from account 2. And this has been successful. And now if we check the balance of account 3, and remember it hasn't mined any coins, it should be 3. And the balance of account 1 should be 2. and the balance of account 2 should not have changed. So it's still 8. And the total supply should be 13. So let's check if that's correct. Alright, so everything has worked. I hope everything is clear. Now be aware that, as I mentioned in the development environment setup video, TestRPC node is only a simulator of an actual Ethereum node. Thus, it cannot be used for testing performance of a smart contract. And also, all the work that you do on a TestRPC node is gone once you close it. Everything is temporary. So just be aware of that. In the next lesson, we will have a look at events and how to use them for logging. I'll see you there.